Okay, I'm just about to start this grand experiment. I'm broadcasting live on Facebook at the moment, and this is a bit of an experiment, so we will see how it goes. And it looks like I've got a couple of people joining in. So let's get on with the first lockdown lecture on Bharatiya mathematics. It's day one, so welcome aboard. We're all in the same boat together during this time of coronavirus, so I thought, why not create some lectures which will be recorded on Facebook live and also made available on YouTube. So, as the screen says, Namaste. I've got the next slide. There I am, Jonathan J. Crabtree, founder of Podometic.in. And I'm getting a couple of comments coming through on Facebook. Hello, Andrew. Thank you for your comment. Thank you for Sumyadeep for saying stay safe. I'm not going to be able to read all of the comments on Facebook Live because I've got two computer monitors, two cameras, another laptop running. So this is genuinely multitasking. So this is welcome to your Podometic lockdown lecture number 1. And this is about India's upgrade of inferior British arithmetic, which, as you may know, is based on Greek mathematics. So the arithmetic that we are taught in school is GRECO ANGLO. It's Greek and English, and it's known as arithmetic. And it's based on the counting numbers 1, 2, 3, 4, 5, and so on. But for many, many centuries, the English didn't even consider 1 to be a number. And you'll see that there's no 0 in the original creation of arithmetic. Now, if we compare that to Podometic, we can see that Podometic, the way I've structured the mathematics system, it's built on Bharatiya maths. And Podometic is built for 0 as originally defined by Brahmagupta in the year 628. So the Podometic lectures, they're based on the concept of 0 being the most important concept, which, as it happened, never got out of India. It was misunderstood in the Arabic world, never got to Europe. So the Podometic structure, it's all about 0 and the logical symmetry on either side of 0. So off to the left of the screen, we've got 1 negative, 2 negatives, 3 negatives. And on to the right of the 0, we've got 1 positive, 2 positives, and 3 positives. And you'll see, if you're paying attention, that I'm starting to change my language a little bit. I'm not talking about -1, -2, and -3. I'm talking about one positive, 1 negative, 2 positives, 2 negatives, 3 positives, and 3 negatives, because you'll subtly pick up changes in the way I talk about the grammar of mathematics, which helps in your comprehension. So keep those comments and questions coming through on Facebook Live, but I'm not going to be able to answer whilst I'm doing this talk, but I will be able to read them later on. So let's turn to the curriculum of Podometic, and the curriculum is a colour-based curriculum. Now you might wonder why I'm using colours in my mathematics system. Well, it's because Bharatiya maths, they also used colour in their mathematics as well. In Bharatiya mathematics of the time of Aryabhata, Brahmagupta and so on, colours represented variables, unknowns. So I'm thinking, why not embrace all the styles of thinking, and a large part of the attraction of mathematics comes from the colour. So here we've got Podometic, and you can see from the right hand side it's got red, and then moving towards the left, orange, yellow, green, blue, indigo and violet. And you can see the children, the red child is a lot smaller than the violet child. So each year of the mathematics curriculum has its own colour. And as it happens, I am wearing red. So if you read the fine print underneath where it has Podometic at the top, it says the world's zero-based arithmetic upgrade, and it's a primary level maths rebuilt in the tradition of Aryabhata, Bhaskara and Brahmagupta. So let's delve into the curriculum colours. And what we have is we have rainbow colour classes. So what we're going to be doing is now we're going to be focusing on some of the ideas for class 1. So here we've got class 1, the Podometic Conceptual Empowerment Pedagogy, and this is for use alongside the Indian NCERT class 1 curriculum. So you'll be able to follow the lessons that I give, and they'll be consistent with the type of knowledge that you'll be learning at primary level classrooms in India. So what do I cover? I cover the physical foundations of this mathematical system called Podometic. I also cover the numerical creation, also ideas of correspondence, and of course counting. So I like to mix things up a little bit and get people thinking about many different things. So I'm sure that right now, when we're in lockdown all around the world, we'd love to be at the beach. And I've got a message from Radi coming through. He's watching online right now. And here we've got the beach. So let's have a look at the beach. And the beach I'm going to call ground level 0. And on ground level 0, there are no bricks and there are no holes. So if there are no bricks and there are no holes, that's why we're saying there's 0 bricks and there are 0 holes. Now, imagine that we take a bucket to the beach, and we also have a spade, and what we can do is start to dig and make bricks, and we can make holes. And there's an example of a brick. There's an example of a hole. Many of us will have memories of playing with a bucket and spade, digging holes and making bricks by filling up the bucket and turning it upside down. We might have called them castles or bumps or whatever, but you are familiar with this idea. So let's go to the beach for a moment, and let's start at the beach. And in case you're wondering, Podo the puppy, which is the cartoon character that I use throughout the Podometic ebooks, is real. And there she is. And if I just click, you'll see there she is. That's my real dog at the beach. And there we have a hole. So Podo is a real dog. So here are some questions. Now, bear in mind, this is class 1. So the children are going to love the cartoons, but the concepts are rather deep. So let's have a look here, and we can just ask children, do you think this is true or false? And you might use different words. You might say, does this look like it's possible? And the children will probably say yes, because Podo has dug 1 hole and she has 1 brick. So we move on to the next question, and we say here, is this true or false? And the children will say, well, yes, Podo's dug 2 holes and she's made 2 bricks. Now, what about here? Is this true or is this false? And the children will say, no, that's silly. That doesn't make any sense. And the teacher or the parent or the older brother or sister can say, why? And the child will say, well, Podo's got 2 bricks, which she's stacked up one on top of the other, but there's only 1 hole. True or false? And this time it's a little bit different, but the children will probably agree that that's true, because Podo's got 2 bricks, she's got 2 holes, and so it's all okay. What about now? There are 3 holes side by side, and as you can probably work out, there are 3 bricks that have been, one of them has been put on top of the other one. So we can then have a bit of a discussion about the bumps or the bricks and the holes, and you'll see that they should always be having a 1-to-1 correspondence. Every hole creates 1 brick, and you can see there's in the middle of that slide there's a picture of me and Podo at the beach together. So bear in mind, I've spent more than a decade walking along the beach, thinking about mathematics, walking Podo, and imagining how would I explain mathematics to a dyslexic, hyperactive child or a puppy. And so I was making everything as simple as possible in explaining this mathematics. So let's go and have a chat with, or not a chat, let's look at Podo the puppy. Here's Podo. I am from a town called Metic. Let's go there and play. So from ground level 0, I make equal numbers of bricks and holes. And then you can see there are 3 holes and there are 3 bricks. For every hole, there is a brick. From ground level 0, I make as many bricks as I make holes. Now this is all about the concept of correspondence, and you'll get more of these ideas starting to come through to you. So let's see what Podo does. Equal numbers of bricks and holes put together make 0 bricks and holes. So here's the 1-to-1 correspondence, a brick in a hole, there's a brick in the hole, and there's a brick in the hole, and put together, as many bricks as holes put together make 0 bricks and holes. So this is actually starting to inform children of the physical foundations of quantity. And mathematics is all about relationships between quantities, and numbers simply count or measure quantities. So we're starting off with physical foundations of Podometic that are easy to understand. So here we go on to playing Podo 0 up, and we explain the words we use to count are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So here's Podo, starting off with 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Bonk. Oh no. What's going on? Whoops. Podo wondered who the naughty puppy was that knocked the stack of bricks over. It was hot and tiring work, so Podo decided to try again when it was cooler. That afternoon, Podo played Dig It. For every hole, there is a brick. And there you can see arrows connecting the bricks to the holes, and it doesn't matter which brick is matched with which brick is matched with the hole. There's going to be enough to make 0 bricks and holes when they're put together again. So 10 bricks and 10 holes put together make 0 bricks and holes. So playing Podo 0 up, the symbols we use to count. Last time we had the words, this time it's the symbols. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I've got a bad feeling. 10. Bonk. Not again, says Podo. And I did it again. Now, how can I stop that puppy knocking down my stack of 10 bricks? And Podo has a great idea. But we're not going to be talking about that idea now, because this pedagogy of Podometic comes back to ideas. It raises curiosity, and it wants children to have a think about what Podo might do to solve the problem of the stacks of 10 bricks being knocked down and being unstable. We've introduced counting with words and with symbols. Now we're going to start to look at the quantities involved with the individual digits. So here we move on to matching and counting. So you can see we have 0, and there's the word 0. We have the digit 1, and we have 1 square, or it may be 1 brick. 1. There's 2. And you can see that the digits have podules, which are little circles which represent the quantity that that digit summarizes or symbolizes. So there's 3, and you can see that the 3 digit has 3 podules, and there they are connected onto the 3 bricks. There's 4, 5, 6, 7, 8, 9, and there the 9 digit has 9 podules, and they all connect onto 1 brick. So 1 podule only ever connects to 1 thing. Okay, so for example, 9 cows. For every podule on that digit 9, there is a cow. So the digit 9 can start to be connected with 9 objects, whether it's 9 flowers, 9 fish, 9 buttons, 9 apples. They can all be connected with that digit 9. Hello, I'm Zaki. Draw digits from 0 to 9. Connect and count dots, and you'll do fine. Every digit has as many dots as the number of things it counts, and 0 does not have any dots. So we're starting to teach children how to actually draw the digits. So I've gone back to the slide here, and it's just a fun game of dot to dot that helps the children to start to draw the digits. As you can see, the drawing of the digits will be a lot of fun for the children. So here we've got Ash the Eagle. I'm Ash. Help me count and combine the dot digits. So here we've got 2 plus 4 equals, can you find a digit that has as many podules? Well, there's 1, 2, 3, 4, 5, 6 podules altogether. And when all the dots are counted once, you stop. And so 6 podules means that 2 plus 4 equals 6. Okay, so we've got a variety of others that we can explore. 2 plus 7, 1 plus 8, 3 plus 5, 3 plus 6, and so on. We can get to counting. We can also then go on to adding. So here we've got 2 cows, and we've also got 3 cows. So the podules on the digit 2 connect to 2 cows. The podules on the digit 3 connect to 3 cows. And there you see the only digit that has as many podules as there are in 2 and 3 is the digit 5. And you can connect each podule on the digit 5 to one of the things it's counting. So 2 cows and 3 cows are 5 cows altogether. And there's the alternative in words. 2 cows and 3 cows are 5 cows altogether. So we use a combination of symbols for the numbers and also the words for the numbers as well. So we can then Count them. 1, 2, 3, 4, 5. So 2 cows plus 3 cows equals 5 cows altogether. So 2 plus 3 equals 5. And there we have a picture of 2 cows, and plus 3 cows equals 5 cows. So instead we can start to practice drawing the digits, and also when we're doing our counting, we can match the quantity of objects with the digit. And you can see here we've got the digit 1 is matched with the stack of just 1 brick, and the children can join the numerals with the correct stack of bricks. And we will start to move away from having digits with the podules on them once the children get familiar with writing those digits. So what I'm going to do is I'm going to finish this first introductory lecture at this point. So we've covered quite a few things, and I think it's appropriate. The lectures that I'm going to be doing are going to run from anywhere between 20 minutes and maybe 40 minutes. I hope that you've enjoyed this first Podometic lockdown lecture, and it went reasonably smoothly. A little bit of an experiment. So thank you very much. This has been Jonathan J. Crabtree, the founder of Podometic. Thank you very much. Take care, look after yourself, wash your hands, practice social distancing, and together we'll get through this lockdown, and we've got more lockdown lectures to enjoy coming up. So thank you very much for watching. I'll see you again soon.